Well, hello and welcome back to Mr. Haas's math help videos. Okay, so we're talking about lesson 21. Lesson 21 is creating equations with tables and graphing them. We're kind of pulling it all kind of together. So, first thing we're going to look at is coming up with equations from word problems. Of course, they're going to give you a bunch of words, and then we have to kind of figure out what it is our equation's going to look like. So let's say that you read a book, all right? You're going to read 7 pages per hour, all right? So an equation is going to need a variable. Well, why don't we put in the letter H for hours, okay? H is our variable. That's, you can change the number of hours that you spend reading. So, but if you read at the same rate, then you're going to have to multiply that by this constant, the number 7. For each hour that you read, you're going to get 7 pages. Well, for it to be an equation, remember we have to have the equal sign. Okay, so there's our equal. And what is this going to equal then? So if I multiply 7 times the number of hours I read or you read, we're going to get the total number of pages. So I'm just going to use the letter P for pages. And that's our equation. And it can be rewritten just like this. Notice I didn't put the dot in there saying that it's a multiplication problem. It can be written either way. The variable, your dependent variable can be out here and your independent variable over here. Either side, flipped, doesn't really matter. Okay, so that's just really simply taking the information they give you and turning it into an equation. All right, now, let's say you go to a movie, okay, and your ticket costs you $10. It's about average price to get into a movie these days. And when you go to the snack bar, each food item, all right, that's your popcorn, that's your soda. They're having a kind of all for one price. Each food item, each food item, candy, popcorn, soda, is going to equal $5. Good deal, right? That's expensive stuff. Let's let F be our food, okay? F equals food items. We want to know what the total cost is going to be for our trip to the movie, depending on how many of these food items we eat. All right, so to write an equation, I'm going to put T for our total cost. And what's that going to equal? Well, you got to pay that $10 to get in, right? So there's your $10. But you're also going to have to pay how much? $5 for each food item. Okay, so see how I'm doing this? $10 to get you in, plus $5 times each food item that you buy. So this is our equation right here. And so here's our independent, because it all, depending on how many of those food items you buy, that's going to determine how much your total cost is going to be. I mean, you walk in, if you just pay the $10 and you don't buy any food items, you're just going to get it off for $10. So, I mean, if that's your independent variable 0, then you're going to end up with just a total cost of 10. Well, let's see about putting this in a table, okay? So it's really easy. So here's our table. Right. And this is going to be our food items. And this is going to be our total cost. This is our independent, and this is our dependent. I'm going to put a capital I there. Independent and dependent, these are our variables. So whatever we do in this one is going to change this one, okay? So a lot of times we want to know how much it's going to cost before we get out. So let's say we eat 1 food item, 2 items, 3 items, 4 items, 5 items. Okay, well, our total cost, if you look at this, it's going to be $10, right? Plus 5 times 1. 5 times 1 is 5, plus the 10, it's going to cost us $15. If we buy 2 food items, we still got that $10 we got to pay, plus 5 times 2. Well, 5 times 2 is 10, plus the 10, that means it's going to cost us $20 to go to the movies. And this continues on just like this. Each time we add a food item, now we've got 3 here, and that would be 25. And 10 plus 5 times 4, that's going to be 5 times 4 is 20, plus the 10, that's 30. And here if we do 10 plus 5 times 5, 5 times 5 is 25, plus the 10, that's 35. Okay, so how much more is it costing us each time we add a food item? Well, that's pretty easy. We actually told us right up here. Each additional food item is going to cost us $5. And if you take a look at our table, yeah, each time we add one, it goes up by $5. Okay? How about this? Can we use this equation to answer this question? How much would it be if you were just like really hungry and you got a hot dog and a popcorn and a soft drink and a couple candy bars? What if you got 8? What if you got 8 food items? Oh boy. Well, you're going to have a pretty big bill. So let's figure it out. So here's our equation again. 10 plus 5 times 8. We're going to put that 8 in for the F for food items. Well, 8 times 5 is 40, plus the 10, that's going to be 50. See how you can use this equation? You can use equations to help you figure out how much something would cost way out there in the future. How about 15 items? What if we did 15 food items? Well, let's plug it in. Foods. All right, 10 plus 5 times 15. Oh my God, that's a lot. Maybe you were sharing with a friend. 15 times 5 is 75, plus the 10, that's 85. Well, I hope your parents were helping you out with that cost. That's a lot of money to go to see a movie. All right. Could you buy 3.6 food items? No, you can't. You go up there, hi, I'd like a drink, and I'd like a candy bar, and I'd like 6/10 of a bag of popcorn. No, they wouldn't sell it to you like that. So it's got to be a whole number. So in this case, in this particular problem, you really can't do that. You could plug it in; it'll work. I mean, you could figure out the total cost, but in this particular situation for this problem, you can't do it. You can't do that many food items. That's like saying I only want to watch half the movie, so I'll leave halfway through. So I only charge me $5. Isn't going to happen. So, all right. So that's done. Let's talk about a little bit more of these equations. So let's see if we have an equation that is y is equal to 4 times x plus 3. Okay. Remember, this one's our independent because this is what we can change. We decide we want to change. And this number over here, that's our dependent variable. That's what's going to happen. It's going to change because every time we change this, that's going to change. Okay? You don't generally do that. So if I was to ask you which one's the independent variable, well, this is our independent. Let me write it out. Independent is equal to x. That's our x. And the dependent variable is equal to y. Remember, this is a constant. That's our coefficient, right? So those things are good. If we made a table to show the relationship between our independent and dependent variables, x and y, here. If this is our x and this is our y, okay? And I'm going to plug in some numbers just randomly. Let's pick 1 and 0 and 2 and -1 and minus 2. How about all those? Okay, so if I put in 1 for x, 1 times 4 is 4, plus the 3 is 7. So when x is 1, y is 7. If I put in 0 for x, 0 times 4, well, that's 0, plus 3 is 3. So when x is 0, y is going to be 3. If I put in 2 for the x, 2 times 4 is 8, plus the 3, well, that's 11. So when x is 2, y is going to be 11. Minus, what's happening here? Well, minus 1 times 4 is going to give us a minus 4. Okay? Remember, when you're multiplying a negative times a positive, you're going to get a negative. Odd number of negatives gives you a negative number. Even number gives you a positive. Okay, so negative 1 times 4 is negative 4 plus 3. Well, that's going to give us a negative 1, because negative 4 plus 3, a little bit negative still. All right, let's try putting in negative 2. Negative 2 times 4 is going to give us negative 8, plus 3 is negative 5. So when x is negative 2, y is going to be negative 5. So this would be actually coordinate pairs. So whenever you are looking at the independent variable is always going to be that x. It can be any letter you want in here, but it's going to be the one that is on that horizontal axis, okay? So independent is going to be along here, along this line. They're going to do that one first. Notice xy coordinates. So this would be an ordered pair of 1, 7. This would be 0, 3. This would be 2, 11, and so on. This is just how an equation can become a ordered pair and actually then a line. And this would be our dependent variable. Dependent variable would go up here. So independent, dependent. So we just plot them that way. When the x value is this much, the y value turns into that. Okay, good. So we got that down a little bit. So let's say we've got a t-shirt company. They make custom t-shirts for, like, sporting teams or whatever. They charge a flat fee for design. So our design is going to cost $15. They say, hey, you want your team to have a really cool design on your t-shirts? We got it here, but we're going to charge you $15. Then we're going to give you the discount price. Each t-shirt, right? That's going to be $4. Okay, so for each one you buy, it's going to be $4, but we got to also charge you this $15. So the more you buy, the cheaper each one's going to get, right? Well, we'll see. So what kind of an equation would this look like? Well, I'm going to use C for cost. That's our total cost. That's what the whole bill is going to be. We're going to have to pay that $15, aren't we? We got it, no matter what. We got to pay that $15. Plus, for each t-shirt, we got to pay $4. Okay, and there's a variable involved, right? Our independent variable. In other words, dependent on how many we decide to buy. Well, what do you want to use for that? You want to do T for t-shirt? Okay, let's do a T for t-shirt. All right, so there's our T. So if we buy one t-shirt, well, it's going to be 1 times 4. That's 4. Plus the 15, that's going to be $19. Okay, so we could make a table if we wanted to really quick. And I'm going to just use the letters of these two variables, okay? And it's going to look like this. This is going to be our T for t-shirts, and this is going to be our C for cost. If I do one t-shirt, that's going to cost me, what, 19? If I do two, that's going to cost me, let's see, 2 times 4 is 8, plus the 15, that's 23. Could I just say, hey, you know what? I don't like your design, so I'm not going to buy any t-shirts, but I still got to pay you for the design? Yeah, that's going to be $15. How about for 3 t-shirts? Well, that'd be another $4, right? Because each time we go along, it increases by $4, right? Each additional t-shirt we buy. But just in case, let's take this. 3 goes in for the T. 3 times 4 is 12. Plus the 15, well, that's 27. Hey, and take a look back here. Here's where we had 2, and it was 23. Now it's 27. Take a guess. What do you think? How much for 4 t-shirts? Yeah. Well, let's just add another 4 to that. That's going to be 31. Try it. 4 times 4 is 16. 16 plus 15. Well, that's 31. That's exactly it. Let's do a quick graph. All right, we're going to graph this. This is our total cost. And this is the number of t-shirts. Okay, here's our 0. This is going to be 1 t-shirt. It's going to be 2, 3, 4. I guess I could put in 5, but we're not going there. Here's 5, 10, 15, 20, 25, 30, 35. Good. All right. So when we have 0 t-shirts, no t-shirts, it's going to cost us $15. When we have 1 t-shirt, we add 4, that's 19. That's just a little bit below 20 here, so I'm going to put my next dot here. When I've got 2 t-shirts, that's 23. Here's 2, follow it up. 23 is about in here, so right about in there. 3 t-shirts, that's 27. That's just a little above here, so about there, right? 4 t-shirts, that was 31. That's just a little bit after the 30, yeah, right there. Look at this. A straight line. That's why they call these linear equations, because the result is a line. And that's what linear is. Okay, great. Hope you enjoyed the video. I'll see you in class. Bye.